Factorization of polynomials is among the most useful pre-calculus techniques in calculus. In this video, we will review some basic techniques for factorizing quadratic functions. We will start with the common factor technique, which is rather simple but also limited. Then we will review some formulas, including the difference of squares formula and the complete square formula. The three techniques here, the product sum, cross multiplication, and grouping, are three trial and error type of method that will allow you to factorize all the quadratic functions that you will see unless they cannot be factorized at all, or the factorization involves some very complicated square root. For those functions, they can still be solved using the complete square method or the quadratic formula. Let's start with our first example. Here we have a function that has two terms, and you can see that these two terms have a common factor, which is 3 coming from 3 and 6, and then x coming from x squared and x. In other words, you factorize each term in the following way, and then you take out a common factor 3x. So this is called a common factor technique. Very simple. Let's look at a different kind of technique called using formulas. Here is one of the formula, difference of square formula. Basically, it says if you take the difference of two squares, a squared minus b squared, then it can be factorized into a plus b times a minus b. Okay, very, very useful. Let's look at this example here, x squared minus 9. Okay, so 9 is equal to 3 squared, so you write this as x squared minus 3 squared. And now you can apply the formula where a is x and then b is 3 here. Therefore, by the formula, it's a plus b, which is x plus 3, and then a minus b, which is x minus 3. Okay. There is another formula called complete square formula. It says a squared plus 2ab plus b squared is equal to a plus b squared. Okay. If you replace the sign in the middle by subtraction, then you have a similar formula here. You can think about that as just replacing b by minus b, and it will simply imply that other formula. Okay. So if you look at it here, this example gx is x squared minus 12x plus 36. Okay, first thing you want to do is to try to rewrite this in the following format, in the complete square format. So x squared is just x squared. This is our a squared term. And then you need a 2ab. Well, 12 is 2 times 6. So you write 2 times 6 times x. So this is our 2, and a is x, and b is 6. And then b squared, so you need a 6 squared, and 6 squared happen to be equal to 36. So this is a complete square format. Therefore, by the formula, it is equal to a minus b squared, which is x minus 6 squared. Okay? Now, for this problems, for both problems, you have to be lucky in the sense that your question has to fit into this standard form. So for example, if this number is not 36, let's say 40, then you have to do some other work. Okay, so I mean, same for this one, it has to fit into a squared minus b squared format. Okay, now let's look at examples where they don't fall into those kind of format. Well, before we do that, let me also mention that these formulas have can be generalized to a more general way. So instead of a squared minus b squared, you can have a to the third minus b to the third, or a to the nth power, a to the 10 minus b to the 10. I hope you see a pattern here. Basically, you start with a minus b, okay, and then the power of a goes down. So like 2 and a to the 1, and here you have a to the 0. Similarly here, 9, 8, and then that next will be a to the 7. and then the b power goes up. So you have a b to the 0, b to the 1. So here you would have b squared and so on. Okay, so perhaps you can see a pattern here. I won't go through the details for this here, just to mention you the fact. For the complete square formula, you also have a complete cubic or nth power formula. So for example, a plus b to the third power is equal to a to the third plus 3a squared b plus 3ab squared plus b to the third. Basically, the power of a goes down like before. The power of b goes up. And then the coefficients, they satisfy the so-called Pascal-Young triangle. I might want to provide a different video sometime on those two formulas. Okay, so those are the two formulas, a squared minus b squared and the complete square formula. Okay, as I said, most problems will not fit into those kind of formula. Like for example, x squared minus 6x plus 8. This is not a complete square, because if you try to write this as a 2ab, you're going to have 2 times 3 times x, and then you would need a 3 squared, which is 9, but you have an 8 here, so it won't fit. All right, but this can be solved easily using the something called a product sum method. Basically, you want two numbers whose product is 8, and then the summation is minus 6. Well, given 8, there are a few possibilities. Like 1 times 8 is 8, or you can have a minus 1 times minus 8, or you can have 2 times 4 is 8, or minus 2 times minus 4. Okay, so these are the 4 possibilities here. You want to pick the one for which the two numbers add up to be minus 6. Obviously, this one will not work because 1 plus 8 is 9, which is not minus 6. And this one will work. So minus 2 and minus 4, and they do add up to be minus 6. Okay, so you pick this choice, and that means the answer is x minus 2 times x minus 4. That's it. It's always a good idea to double check. Let me just do this mentally here. So if you multiply this, x times x is x squared. And then here you have a minus 2 times x, and minus 4 times x. Well, minus 2 and minus 4 gives you minus 6, so minus 6x. And finally, a minus 2 times minus 4 gives you 8. This also shows why you want the product to be 8, summation to be minus 6. Okay? Because when you verify, compute the product, it has to give you the original problem. Okay? So this is called a product sum method. It's fairly simple. Let's just quickly do another example. So here, x squared plus 2x minus 15, you want a product, well, 15 or 1 and 15 or 3 and 5. Well, for 3 and 5, you want to get a 2. So if you pick a minus 3 and a positive 5, that will work. Okay, so notice minus 15 is positive 5 times minus 3. Okay, and if you take the summation, it gives you 2. So that means the answer should be x plus 5 and then x minus 3. That's it. Fairly simple. Now, I should say that the product sum method works only when the coefficient of x squared is 1. If it's not 1, if you try to use a similar idea, then you end up with something called a cross multiplication. It's really the same idea, except that the coefficient here is not necessarily 1. Okay, so here is one example. Okay, so basically, if you follow the same idea as before, you want two numbers whose product is 2, and then another pair of numbers whose product is minus 6. And then when you do cross multiplication, it should give you the midterm, which is minus 1. Well, here, let's see. These are actually all the possibilities. Let me explain this. So for 2, you could have 2 times 1, or you could have, you could have a minus 2 times minus 1, but really it's the same in this case because you can adjust the sign in the second pairs of numbers. So I'm going to just pick 2 and 1 here. Now for minus 6, you could have 1, 6 or 2, 3. Okay? So here we have all the 2, 3 cases. It could be minus 2 and 3 or 2 minus 3, or you could put a minus 3 and a 2 and 3 minus 2. Okay? Then if you do cross multiplication, what does that mean? You cross multiply 2 times 3 and then 1 times minus 2. Okay, 2 times 3 is 6. 1 times minus 2 is minus 2. 6 and minus 2 gives you minus 4, so this will not work. Okay, because you do need a minus 1 here. Let's see which one works. So I think this one will work because here you got a minus 4 and then 3 minus 4 and 3 gives you minus 1. All right, so this one works, and that should give you 2x plus 3 from the first row, then x minus 2 from the second row. All right. Okay, so okay. Again, it's a good idea to double check. So you can multiply this, and that should give you the answer here. Let's see. 2x times x, that's 2x squared. That's really because we already did make sure that 2 times 1 is 2. So, and then 3 times negative 2, 3 times negative 2 is negative 6. Again, because of the way we choose, 3 times minus 2 is already minus 6. And then if you multiply 3 and x, that's a 3x, and then 2x and the minus 2, that's negative 4x, and that gives you minus x. And again, that's because you do already checked cross multiplication gives you minus 1. Okay, so that's cross multiplication. Again, they are similar ideas, but cross multiplication works more generally when the coefficient here is not necessarily 1. So by the way, you can easily check that the example we did earlier, you can also do this by cross multiplication. So basically 1 times 1 is 1, 5 times negative 3 is negative 15. You cross multiply and it gives you 2. Okay, and then you get the same answer. All right, well, these two methods pretty much solve all the problems that you will see. Sometimes people prefer this other method, which is called a grouping method. It's really the same as works, it's the same problems. It can be solved using either method, cross multiplication or grouping. I'm going to just show you this example and leave it to you to read the details. I won't go through the details here. So basically you have this example here, and grouping mean, okay, so before you group them, you want to multiply the leading term, which is 2, multiply that to the last term, the constant term, which is negative 6. So 2 times negative 6 is negative 12. And now you try to factorize negative 12 into 2 numbers so that the summation is the middle one is minus 1. So the one that works is negative 4 and 3 because they add up to be minus 1. Once you have that, then the grouping just means that you split the minus x into, based on this, minus 1 is minus 4 plus 3, so you split that into minus 4 and 3. And now you group them, okay? For each of them, you take out a common factor, then magically there will be a common factor, okay? It's really, again, I won't explain why this works, but it really follows from the same idea as before, okay? As I said, those 3 methods will take care of all the problems, the simple problem that you run into. But sometimes you will have a problem that cannot be solved because they cannot be factorized, or because the factorization involves some complicated square roots. For those functions, you can solve them using the so-called completing square method. Okay, this method is very powerful. It's so powerful, it solves every quadratic function. Okay, it can factorize every quadratic function, unless it cannot be factorized. And when they cannot be factorized, this method tells you why it cannot be factorized. Okay, so let's look at this example here. before we do this, let's remind our complete square formula. Again, a squared plus 2ab plus b squared is equal to a plus b squared. Okay. First thing you want to do is try to fit this into that format. Okay. And then after that, you're going to need another formula, the difference of square formula, which we also just learned a minute ago in the previous slide. All right, so let's apply the first formula here and try to fit this into this. Okay, so that's your a squared, and 6x is 2 times 3x. Okay, so 2 times 3x. Okay, so this is our a, so a squared, 2ab, and b is 3, so 3 squared. All right, so because you added a 3 squared, let me subtract the 3 squared to balance that. And then you still have the plus 3. Obviously, this is equal to the same as before because 3 squared cancel each other, and then everything is the same as before. So now you group the 3 terms together and apply this formula. That gives you x minus 3 squared. Okay? And then here you have a negative 9 plus 3, that's a negative 6. Now, to factorize this, you apply the formula here, a squared minus b squared. This is our a squared, and for b squared, well, 6 is equal to square root of 6 squared. Okay, so now here's your a squared and then b squared. Now by the formula, it's a plus b, a minus b. Okay, this works all the time. Okay, when does it not work? Well, when you have a plus, like for example, if I change the problem so that this becomes a plus 6, then you cannot apply the formula, and in fact that cannot be factorized. Okay. Let's talk about a quadratic formula. This is yet another method by using formula that can factorize any quadratic function. And when the function cannot be factorized, it will tell you why it cannot be factorized. Okay? First, let's remind us the following. If you have a quadratic equation like this, then there is this quadratic formula that says the roots of this quadratic equation is the following. Okay? So negative b plus minus square root of b squared minus 4ac divided by 2a. Typically, there are 2 roots. Sometimes it could be 2 equal roots if this number is 0. Okay? So given the 2 roots, and you call them x1 and x2. And then once you have that data, then this quadratic function is just equal to x times x minus 1, x minus x1 times x minus x2, and then you still have the coefficient a in the front. Okay? So the key is to find out the roots using quadratic formula. Let's see how this works by applying this to this example. First thing you want to do is to find out its roots. Okay? So apply the formula. A is 1, b is minus 6, c is 3. By the formula, the roots are, so negative b, so negative 6, that's plus 6. And then b squared minus 4ac, this is b squared minus 4ac. And then 2 times a, so 2 times 1. Okay? If you work this out, the number inside square root is just 24. And 24 can be factorized into 4 times 6. And square root of 4 is 2, so that's why we have 2 times square root of 6. And then you cancel out the 2 with the bottom, so you have 3 plus minus square root of 6. So that means x1 and x2 are those 2 numbers. And then a is equal to 1. So by this formula, our function is just a which is 1, x minus x1, so x minus this, and then x minus x2. Okay. This works for all the problems. Sometimes the question may be it may not be factorized. That's when this number here is negative, because you cannot take a square root of a negative number. Okay. So in general, we can have the following kind of a summary of when a quadratic function can be factorized. It can be described in terms of the discriminant. The discriminant is defined to be b squared minus 4ac. In other words, it is what's inside this square root. If this number is a positive or 0, then this expression is going to be the square root of this expression is a real number. So we have two real roots, or maybe two identical real roots if it's equal to 0. So in that case, this whole idea will work. You can just write down the factorization using this. But if this number is negative, then you run into the issue of a square root of a negative number, which cannot be real. So in that case, you cannot factorize over the real numbers. Okay? And if this is equal to 0, then again, it can be factorized. In that case, those two numbers are the same. So we have x minus x1 squared. So it becomes a complete square. Okay. Let's look at an example. So here, for this example here, you can calculate a b squared minus 4ac, and that is equal to 24 as we did before. Therefore, we can't factorize. In fact, it was factorized here. If you look at this example here, then b squared minus 4ac, so b squared, that's 1, minus 4ac, that's 4. So that is equal to minus 3, which is a negative. That means if you try to use this formula, you're going to run into square root of negative 3, which is not a real number. Therefore, it cannot be factorized over the reals. Let's look at another example. If this is plus 9 here, then b squared minus 4ac, so b squared, that's 36, minus 4ac, that's 36. So that is equal to 0, and therefore you can factorize and you have a complete square. In fact, we did this. It is a complete square, which is x minus 3 squared. Okay? So this gives you a complete classification of when a polynomial, a quadratic polynomial, can be factorized. And when it can be factorized, you can use this formula to factorize, or you can use the complete square method to factorize. Or if this square root is a very simple number, then you can use the previous method, which is like a product sum or cross multiplication, and you can factorize that way. Okay, that's all. Let me just quickly give you a summarize. So first we talk about a common factor method. This is very, very simple and only fits certain special functions. And then we talked about product sum, cross multiplication, and grouping. Those are the three trial and error methods. The basic idea is to find out, how do you factorize a number like a 12, because 3 times 4, it could also be 2 times 6, and so on, or 1 times 12. Then you try to find out which of the factorization can give you the factorization of the polynomial. And then in certain special case, when the function fit into those format, then you can use those formulas. And then if none of those work, then we have this tool here that works for all functions. So complete square or quadratic formula. Okay, that's all.